All right, so let's take a look at the next principle, which is called the Liskov Substitution principle. Now, this principle is about inheritance. Now, we've been talking about the importance of inheritance, and also with inheritance, you can implement the polymorphism, which is a very powerful structure and design in object-oriented language such as Java. But then this principle tries to answer a question, which is how do we evaluate and measure the quality of the inheritance? Now, everybody knows how to build an inheritance, but am I doing the right thing? Am I using the right parent class? And are my subclasses all reasonable? So that's the question this principle can help us to answer. The principle says like this: the inheritance should ensure that any property proved about supertype objects also holds for subtype objects. All right. In other words, functions that use pointer to reference to base classes must be able to use object of derived class without knowing it. All right. So this is more based on the C++ structure. And all it's trying to say is that if you got some kind of parent class, and the parent class has some kind of methods and behavior and functions, and then when you are building your subclasses, you want to make sure 100% that the subclass can implement all the methods and functions you define in the parent class, and shouldn't be any exception. So let's take a look at this example. Now, this is a very good example that follows the Liskov substitution principle. Now, here we're talking about insurance, and every insurance we got a policy and specify what the insurance covers and what's your rights and all those details. So in the parent class called policy, and then we got three methods called get units of risks, get policy coverage, get risk depth. And then we got two different kind of subclass at this level. One is the homeowner policy for your house, and one is for your car, auto policy. And then both classes can implement all of this, because no matter whether it's a home or auto, now you do have the units of risk to measure the risk, and you also have to specify the coverages, and then you also need to kind of specify the rate steps. Okay, so these methods applies to both subclasses. And the same for these two. And for the auto policy, you got a personal car, you got a commercial car, but no matter what type car it is, you can still implement or override all of these methods. So this is a very good inheritance structure that ensures all these classes, they all follow the things defined here in the parent, and there is no exception. So let's take a look at another example. Now, in this case, we got a interface called bird, and the bird has a method called fly. And we're implementing our very first class called parrot, and the parrot implements bird interface. So you have to implement this method called fly, and parrot can fly. So we just do something right here to specify how we're going to fly. And then to use this object, you define your parent class, an object, and then you can call mimic and you can call fly. All right, so that's one example here, and nothing wrong with it, since the parrot can fly, and that's also part of the bird interface, so that is valid. But now I got a new subclass called penguin, and I also want penguin to implement bird. Okay, no, since we know that penguin some kind of similar to bird, I'm not expert on biology and know exactly how we should classify it, but it doesn't, it's not too crazy to define penguin as a bird, right? So, however, we all know that penguin might be similar to bird, but penguin doesn't fly. But then since the fly method is required by this method interface, so we have to implement it. But there's no way you can fly a penguin, so I'm going to throw an error here to say, oh, penguin don't fly, I can throw exception. And then in this case, if somebody is trying to call this method with a bird object here, if it is a parrot, that's fine, then you call this method, it's totally fine. But if they give you a penguin, then some exception is going to throw. Now, in this case, this class, this hierarchy is not very good because it does not follow the Liskov substitution principle, because this subclass penguin does not fit this parent interface very well, because this one method is not suitable for this class here. and because this subclass doesn't simply have the behavior. All right, so this is really bad. And you might be saying, oh, I have very good consideration here. If something is wrong, I'm going to throw a exception, tell people this is not working. But again, that's not really the preferred way to go. And if you give warning errors, because for the caller, and they do not know what type of the object you are passing, and then they may not expect to receive that kind of exception, right? So that's why we should not have this kind of structure. And then the best way would be to split the hierarchy and then to split and redefine the hierarchy so that all the method fits to all the classes, all the subclasses. All right, so here's another example. Now you got this rectangle class, and rectangle has a height and width, so you got getters and setters because the height width can be different. Now some people are suggesting we should use a square to add a subclass, and because square is kind of a rectangle, it's a very special rectangle that both height and width are the same. All right, but you cannot really reuse the same method because you got to make sure that whenever you set the width, you also set the height, or whenever you set the height, you also make sure the width to be the same, and then you can implement it. All right, so this looks fun, but again, this is not a good hierarchy because this one you're basically changing the meaning, the behavior, the requirements of what has been defined in this parent class. For example, now you got another method that takes a rectangle, and then you set the width and the height, and then you try to calculate the area. And if this is the real rectangle, when perfect, then you got 20. But if this is the actual square, in the way we implement it, then first time you set a 5, and then both will be 5, and the second time we set 4, and both will be 4. And then at that time, it's very confusing. You're not gonna get, you saw this rectangle, and then 5 times 4, it will be 20. But if they give you a square object, then using this code, you're gonna get a 16. So all this kind of unexpected behavior comes because the subclass does not fit the parent class very well, or does not fit that perfectly. All right, so that's why whenever we're trying to define an interface or parent class, you want to make sure that every functionality has been clearly documented, and because otherwise the new developer, they don't know how to extend it in their subclass. They maybe bring or modify the behavior, and that also you can see if you are violating the Liskov substitution principle. That's also going to potentially violate the open code principle because it will require people to make more changes. All right. Anyway, so this kind of figure here shows a good structure. So you got a client. The client is going to rely on this kind of service class, try to call something. And then when you are creating a subclass right here, all right, you're going to make sure that whatever you're doing for this new subclass can 100% replace the current one. If not, then it's going to cause a problem because the client doesn't know when you're going to send some of this class over because there is in the same hierarchy, they can still take it, and that's when the errors will be happening. All right, so ideally, you can do this, but make sure all the subclass methods can fit what has been defined in the parent class. All right, again, just like what we mentioned earlier, it is not good or not valid to define a method that doesn't do anything. And you might say, I'm not going to throw an error for the penguin. I just leave it empty. Again, it is a very bad practice because, again, you are changing the semantic, you're changing the behavior. Right? So whenever that happens, the solution is very straightforward. All you need to do is to split the hierarchy. So for example, you got a bird. You can have a flying bird, you can have a non-flying bird, and then the penguin will fall into the non-flying bird. That's it. In that way, you will not need to have this kind of deal with this kind of challenge issue. All right, so this principle is very practical. Whenever you're having a hierarchy, make sure that all the subclasses can replacing exactly the same kind of things you have in the parent class.